You've already studied the basics of differentiation. We now move on to a slightly more complicated situation when there's a product that needs to be differentiated. Let's think about what that means. If y equals u times v, now that will probably look a bit strange, but let me explain. U is some function of x. V is also some other, probably different, function of x. And the product rule says that if we want to differentiate y with respect to x, so dy by dx equals, then what we get is u times dv by dx plus v times du by dx. That's quite a formal way of writing it. A slightly quicker way of writing it that is still generally understood is to write that the derivative of y with respect to x equals u v dash plus v u dash, where the dash just indicates that there's a derivative. But to be honest, when I'm using this rule, I'm actually thinking a very precise form of words in my head. I'm thinking dy by dx equals the first times the derivative of the second plus the second times the derivative of the first. That's the pattern of words that's going through my head as I'm applying the rule. Now I think we need to look at an example. Let's do a simple one to start ourselves off with. Suppose you were asked to differentiate y equals x squared times x minus 2. Now, you could of course expand that, y equals x cubed minus 2x squared, and you could then differentiate it from first principles, the basic method of differentiation that you learned first. However, if we use the product rule, we can see that we have a function of x squared, multiplied by another function of x minus 2. And so we have u equals x squared and v equals x minus 2. Now if we work out u dash, that's a very easy 2x, v dash just equals 1. And so using the product rule, dy by dx equals the first times the derivative of the second plus the second times the derivative of the first. Gets me to there. Now, this has two terms. We've got x squared times 1, x minus 2 times 2x, two terms, and we can factorise. This term and this term, the highest common factor that they possess is x. If I factorise using that as the common factor, then I have x plus 2x minus 2. And now I can simplify the contents of the square bracket. X plus 2x minus 4, x bracket 3x minus 4. Now, it's a fact that at this stage here, you've done the differentiation. We're not differentiating in these last three lines, we're just tidying up the result of the differentiation. However, it's a really important part of the process because more often than not, you will be asked to find the stationary points or the turning points of this original function. And you can only do that if you set the derivative equal to 0. And your only hope of solving such an equation is if you have 0 equals a factorised format. So you need to get into the habit of whatever you've got here, you factorise it as fully as possible so that it makes it easy to work out the turning points of the original function. Now that was a basic example to start with. Let's look at another one. Suppose you were asked to differentiate this. Y equals x cubed and then I think we'll have 3x minus 2 all to the power 4. Now again, in principle, we could expand that, but with this power 4 in that bracket, that would be a fairly horrible expansion. Multiplied by x cubed, we're going to get a highest power of x to the power 7. It's going to be a bit of a nightmare just to expand it. Then we would have to differentiate it, and then we would have to refactorize that. You don't really want to go through all those steps. The product rule is perfect here. U equals x cubed, v equals 3x minus 2 all to the power 4. And so u dash equals 3x squared. V dash equals, now we've got to be very careful. The 4 comes down, 3x minus 2 all cubed. I think most people are happy with that. But you have to remember the chain rule, because here we have a function inside a function. So not only do we differentiate the power 4, if you like, the 4 coming down and reducing to a power 3, we also have to differentiate the contents of the bracket. And when you differentiate 3x minus 2, that gives you a 3. So if we just tidy that up a little bit, v dash is 12 bracket 3x minus 2 all cubed. Which means that dy by dx equals the first times the derivative of the second plus the second times the derivative of the first. Notice how long the line is getting. You've got to be very careful not to get these tangled up with each other. Now perhaps you're happy looking at this as it stands, but it is quite a tangle. So before we try to factorise it, let's maybe just rewrite it in a slightly more normal order for each term. 12 x cubed 3x minus 2 all cubed plus 3x squared 3x minus 2 all to the power 4. Perhaps I'll make it more obvious as to what the common factors are. In terms of the numbers, a common factor of 3. In terms of the x's, a common factor of x squared. And in terms of this bracket, 3x minus 2 to the power of something, we've got a power 3 here, a power 4 there. So we remove all of that as a common factor. Now what's left? 3 times something makes 12, that's 4. X squared times something makes x cubed, that's x. 3x minus 2 all cubed, we've already got that, so we don't need to add anything in here. Plus, we've already removed that 3x squared, don't need to worry about that. But there is a 3x minus 2 in here, which isn't here. So 3x minus 2 all cubed plus one last 3x minus 2 gets us to there. Technically that's in brackets, but because of this particular question we don't need to write them. Just be aware that sometimes you might need to. So what have we got? 3x squared, 3x minus 2 all cubed, 7x minus 2. And we've differentiated that fairly complicated function. Always be aware that there could be a chain rule hiding inside a product rule. Got to be very careful of that.